Hello everyone, this is the classwork video for May 20th, 21, IM2. So we talked about volume of prisms and cylinders having the generic formula of volume is equal to big B multiplied by H, where big B is the area of the base and H is the height or the thickness of the prism or the cylinder. Okay, so then we're given this shape. Okay, the first thing you should be thinking is, okay, what is this shape called? This shape is called a prism, and it's a rectangular prism, and because we have 6 faces and each of the 6 faces are rectangles, you could have chosen any sides and they would have been, the opposing side would have been parallel to each other. So you could have done that. I happen to have chosen the top, very top, and the bottom surface as my base. And so the shape of the 2 parallel bases, they are rectangles, and calculate the base area. So to calculate this blue shaded area, I just need to multiply it by its 2 dimensions. That's 4 centimeters by 8 centimeters. So that's 32 centimeters squared. Now to that, I need to multiply by the height. Height is like the thickness of how far apart are the 2 bases. Well, the distance from the one base to the other base is 8 centimeters. That's the thickness of the prism. So height is 8. And the base area of the base, we found to be 32. So it's going to be 32 times 8, and you get 256 centimeters cubed. Remember, the unit for volume is going to be whatever the linear unit is to the power of 3, because you're actually multiplying 3 different dimensions. You're multiplying 1 dimension, 2 dimension, and 3 dimension. That's why it's 3D. All right, the next we have a cylinder, and the 2 base shapes are circles. Okay, the shade in the 2 parallel bases, that's circles, and calculate the area of the base. Remember, area of the circle is pi r squared. So the big B is going to be pi r squared, which is pi times r. In this case is 8 centimeters. So that's 64 pi centimeters squared. Okay, now to calculate the volume. Volume is just the big B multiplied by H, where big B is the area of the base. And we just calculated that to be 64 pi. And H is how far are the bases from each other. Okay, what is the distance? It's going to be always perpendicular to the base face. So how far, or the thickness, or how far the distance is from one base to the other, and that happens to be 5 centimeters. So the H is 5, so that comes to 320 pi centimeters cubed. So that's for number 2. Number 3. Okay, what shape is this? Hopefully you can tell that this is a trapezoid, and we have yet identical trapezoid in the back. And then those 2 trapezoids are separated evenly by some distance. And so that's the distance between the 2 bases, and it's always going to be the same wherever you measure it. And that's the height that we are talking about when we're talking about multiplying for volume. So first of all, what is the area of the trapezoid? Trapezoid area is given by B1 plus B2. B1 and B2 are the 2 different lengths that are parallel to each other. Okay, the 2 sides that are opposite, they are parallel to each other. They have 2 different lengths. So you take an average of these 2 lengths, and that's what I'm doing. B1 plus B2 divided by 2. And then to that, you're multiplying by the height of the trapezoid, which is 6.1. And that comes to 7.5 times 6.1, and which, using the calculator, 45.75 feet squared. Now that I've found the area of the base, I can find the area of the volume. Okay, for that, you multiply the area of the base by height, which is going to give you 45.75 multiplied by 8 feet, which is 366 feet cubed. Then number 4, Luca claims there isn't enough information to find the volume, but Mimi thinks she can. Who do you agree with? Well, we are given the area of the base here. The two bases are here. It doesn't really matter how uneven or it is, because if you know the area of the base, the volume is always just going to be the base area multiplied by how far are the two bases apart, and that is 20. So that's the height is 20. So to figure out the volume is big B, which is the area of the base multiplied by h. The area of the base we're told is 10 units squared, 10, and then height is 20, so 10 times 20 is 200 units cubed. All right, so then we move on to the pyramids and cone. Remember I demoed during the class, the volume is of a cone or pyramid is going to be 1/3 of the related prism or related cylinder's volume. So, and that is going to be B times H. So if I have volume as B times H, that is the area of, it's the volume of the prism or cylinder. But if I multiply that by 1/3, that's going to be the related pyramid or the cone's volume. So calculate the base area. Base is going to be this rectangle. Base is just going to be 3 times 2, which is 6 inches squared. And then to that, we need to find the perpendicular height. Okay, that's going to be going from the apex to the center of the shape, the base shape, and that we are told is 4 inches. So h is 4, so 4 times 6, which is what we found here. And then multiply that by 1/3 because this is a pyramid, and so that gives volume is 8 inches cubed. Next, we have a cone. Okay, the circle is my base, and base area is always given by pi r squared, and radius is 12 yard here, so it's going to be pi times 12 squared, which is 144 pi yard squared. Now to find the volume, now that we've figured out the big B, the area of the base, we're told that the height, how far is the base to the tip, okay, to the apex. It is 24 yards, and we're talking perpendicular from center to the tip. Okay, so perpendicular height from the base to the tip is 24 yards, so h is 24 multiplied by 144 pi, and then multiply that by 1/3 because this is a cone. That leaves us with 1152 pi yard cubes. All right, and then number 3, another cone. Okay, this time this is getting a little bit tricky. We're told the diameter is 60 feet. We're told the slant height, okay, is from the apex to the edge of the base, the circle, is 17.9. So this is a slant height. And this is really useful when we're doing surface area, right? Okay, but for volume, that is not helpful. We need a perpendicular height going from the center, joining the center to the apex of the cone. Okay, so in this case, well, first of all, let's find the area of the base. Base is just pi r squared because it's a circle, and the radius is not 16, but it's half of the diameter, so that's going to be 8. So it's pi times 8 squared, which is 64 pi. Now, how do we figure out the height that we need to find? Well, can you picture this triangle right at the center? So you have to sort of, have an X-ray vision and look at the center and be able to visualize this right angle triangle that is at the center of the circle, joining the apex to the tip of the cone. So if I just drop the string with a weight here, it would go down here, and that would be the perpendicular height of the cone. And we know this height, or this length, that is just the radius. From the center to the rim of the circle is just radius. We know the slant height. So this is a right angle triangle. If we know the hypotenuse, and we know one of the leg, we can figure out the other leg. So h squared plus h squared is going to be 17.9 squared, because 17.9 is the hypotenuse. So h squared is really 17.9 squared minus h squared, and that's going to be same as 255.41. So h squared is 255.41. And then when I take a square root of both sides, I actually get h is equal to 16.01. Okay, yes, it is true that you're also going to get negative 16.01, but obviously you can't have the length to be negative, so you just ignore that negative value. Okay, now that we figured out the h and we figured out the b, we can figure out the volume. And volume is going to be 1/3 times area of the base multiplied by h. So it's 1/3 times 64 pi. That's the area of the base. Multiplied by height, we got to be 16.01, or I'm using 16. And so that's going to give us 1024 pi divided by 3 feet cubed. So that's for number 3. And then finally, challenge problem. I hope you had a chance to at least have a look. Okay, this is what we call complex 3D shape. Okay, it is made up by at the top, it's a pyramid. It's a rectangular pyramid, because the base of this pyramid is a rectangle 5 by 3. So you can imagine that this face is same as this face, right? It's just inside. And that's the base of the pyramid here. So it's going to be 5 by 3. So it's a rectangular pyramid. What about the bottom part? The blue part is just a prism, rectangular prism with a thickness of 2 centimeters. So let's start by finding the volume of the pyramid. Volume of the pyramid is 1/3 times base area times height. What is the area of the base? This base is going to have the same area as this, which is 5 by 3. So it's going to be 5 times 3 is the area of the base. And then multiply by the height. Now height, we're told, is from the tip of the apex to the center of the bottom surface is 9 centimeters. Does that mean the height is 9 centimeters? No, it's not, because we have 2 centimeters being taken up by the prism itself. So it should really be starting here. This is going to be the height that we are interested in. This is going to be the height that we're interested in, and this is 9 minus 2. That's the height of the pyramid. Height of the pyramid itself is going to be 9 minus 2, which is 7, and that's what I get. 7 times 15 divided by 3 is like 7 times 5, which is 35 centimeters cubed. What about the prism, the bottom blue part? That's just going to be volume is going to be base area multiplied by height. What is the base area? That's, again, it's a rectangular prism. So it's 5 by 3 is the base, so that's 15. And the height, the thickness is 2 centimeters. So it's 5 by times 2, 3 times 2, which is 30 centimeters. And when you add those two volumes together, you are adding 35 plus 30, which is going to give me 65 centimeters cubed, which is the correct answer. All right, so I hope this made things a little bit clearer. I know I went through this really quickly. So if you need to pause your video and just absorb this, process it, do feel free to do that. That's the beauty of videos. Okay, thank you for listening.